Okay, good morning. How are you? No, so we have a new topic, no? Derivatives of higher order, no? So, what is a derivative of higher order? If you differentiate a function, no, with respect to x, so we obtain a y prime or an f prime, which is also a function of x. And again, if that is again differentiated with respect to the same variable x, the resulting derivatives are actually called as higher derivatives and represented by the following symbol. For the first derivative, we have the y prime. So this is the first time we do the differentiation as this. Okay? So, the second derivative can also be obtained by differentiating further your first derivative. So, this is already a derivative of higher order. So, we can have notation like y double prime. Okay? So, we have another symbol which is this one. This is read as d squared y, dx squared. This means a second order derivative of y, or also denoted with f double prime, also a function in x. In the first derivative of the function, we consider this also as a rate of change of y because it is y that is subjected to differentiation. Okay, and the dy dx means also a slope. So the function that is subjected to differentiation, no, is the one which is subjected to having the rate of change be determined. No? So, if in the second derivative, I am differentiating my first derivative, meaning I'm taking the rate of change of my first derivative. And if my first derivative is a slope according to ganina. So, that means I am taking the rate of change of the slope under the second derivative of function. Further, I can have the third derivative by differentiating my second. No? So I'm taking the rate of change of my second derivative for my third derivative. Fourth derivative. Okay, so have you noticed any difference in the notation used? And for any order derivative of functions or nth derivative of the function, so you have these different symbols. Okay? Now, a while ago, I was asking you, no? So, have you noticed any difference? Okay, so usually, the derivatives with order higher than 3 is represented by a number that is enclosed by a parenthesis. Just like this. Okay? Such as y. This is not power of y, but this is a fourth derivative of your function. And fifth derivative, no? Because the symbol where y is placed or n is placed inside a parenthesis denotes an nth derivative of y. Putting your y with a power with n only, so this can be understood as an ordinary exponent of y. So this is read as y raised to n power. Okay? Now, this is also read, na, tumbalikon, but a while ago ako na siya nangagibasa. So, this is read as d squared y, dx squared. The derivative of y, or the second derivative of y, na, this is lacking. The second derivative of y with respect to x. This means, no, this is an operator. It indicates that y will be subjected, or the function will be subjected to differentiation twice if that is placed beside your y. Okay? So, if we are asked to give a particular derivatives of specific order, okay? Say we are asked to give the third derivative of the function is given, so I cannot go through directly with the third without passing through with the first. So as part of my solution is to give my first derivative. Okay? Since again, we are already gaining familiarization of the formula, so I can go directly to the derivative of every term under the sum rule. So this is a product of 2 and 4. Reducing the power under a power rule, so x to x cubed, no? And do the same. This is 12x squared. That is minus 6x, correct? This is minus 7 because the derivative of x with respect to x is 1. Constant becomes 0. Okay, so that's your first. Continue differentiating and you obtain the second. Okay, so we have 24x squared. No problem with that anymore. That's also 24x. Just reduce the power. And if that is x, then drop your x. So we have minus 6 as the term for the third. This is out because this is a pure constant. My third derivative, which is required, is obtained when the second derivative of the function is further differentiated. This is 48x. That is plus 24. And since it is required, then I can take this as my third derivative of the function being my answer. In the next, now I have y double prime as second derivative. I have a third derivative and my function is this. If I'm going to consider the operation involved in number 2, no, so this is operated under division. So most probably I have to consider a quotient rule of differentiation. But have you noticed that the quotient rule in the list of basic rules of differentiation, that is the one which is most complicated. Okay, so if I can avoid using a quotient rule, then I must. Okay, so instead I rewrite my function as this. With my divisor, which is only x to power 1 half, so I divide every term of my dividend with the square root of x. And this is the effect. Okay, so 4x divided by x to power 1 half minus 5 divided by x with the power of 1 half, Okay, so there I have a terms equivalent to my first term. So I have 4x to power 1 half, because if you apply your law of exponent, the new power of x can be 1 half. Now, 1 minus 1 half. Taking the reciprocal to define my x to contain a power, so I have x to power minus 1 half. Okay? Differentiate for the first time. Okay? Then, second time then. So, we have first derivative. Gikan ini. 4 times 1 half. Reduce the power, 1 half subtracted by 1. We have this. I have 5 times a negative 1 half. So, x with the power minus 3 halves, because this is subtracted by 1. Okay, so this is the value of the term. 4 times 1 half. That's 5 halves, positive, correct? So, x to power minus 3 halves. My second derivative is obtained by further differentiating my first derivative, which is this one. Okay, so 2 times 1 half. Negative, correct? X to power minus 3 halves. Plus 5 halves times negative 3 halves. X to power minus 5 halves. Okay, product becomes 1. X to power of 3 halves, taking the reciprocal to convert it in terms of a positive power. The next term is 15 over 4, correct? That's a product of 2 and 2. Okay? 5 and 3. So, changing the power to positive, I take the reciprocal, I associate x to power 5 halves to 4. So, this is the answer for my second derivative which is needed. So, in the third derivative, if I have to consider this as the function to be subjected to further differentiation, so this is covered under what rule? Katong doon ay c over u to power n. Or if not, if you will be confused, then I think you are already familiar with the power rule, so kanin mo i-differentiate. Okay, just again, familiarization of c over u to power n, I have a negative of c. So I have a negative of minus 1. Then I have a ratio of n over x to u to power n plus 1, no? Okay, 3 halves. Correct. Then x to power increased by 1, 5 halves. Then minus, this is your c. I associated my 4 with 15 para my denominator can only be x to power of 5 halves. Okay? So, minus 15. Okay? And we have this one. So, I apply the rule of c over u to power n is 5 halves. Increase 5 halves by 1. So, this is x to power 7 halves. The value of the term is 3. This is part of the denominator. Okay? So, plus, that's 75. That is it. Okay? So, that is your third derivative. So, you might be interested to express your answer in a similar form as the given. Okay? Kung ato ibutang pa itong given, no? So, I can simplify in a similar form as that. See my second derivative, which is kini. So, I have 2 fractions. I have to combine them as 1. So, I take the LCD for, with respect to x, do nasa ko x with a power which are different. I must use the power which is the bigger. Okay? 5 halves will be used because if that's 5 halves, 3 halves is part of it. No? So, 4x to power 5 halves. Okay? Divide with this. So, we have 4. Kaya ako i-divide in So, 4 times the numerator. It's still 4. How about your x? If that is 5 halves, x to power 5 halves divided by 3 halves, so that means you have x to power 1. Okay? In the second term, this one, exactly the same. So I just copy my numerator. All the terms are negative. I can factor out the negative 1 and express my fraction as negative. Okay? This becomes 4x plus 15. With my denominator, to express that in terms of radical form, so my index is the denominator. So we have a square root of x to power 5. That is your second derivative. Okay? But if there is no required form, okay ra yun if you have to stop until here. My third derivative na can also be done that way. Okay, this one. 2 and 8, my LCD is 8. X to power 7 halves is the bigger between 5 halves and 7 halves. Okay, divide by 2. I have 4 times 3, that's why I have 12. If I have x to power 7 halves divided by x to power 5 halves, then I have x to power 1. So that's why we have x together with 12 in my first term. Okay? My second term, denominators are exactly the same. I copy 75 here. Since this is a fraction, and there may be possibility of reducing this into a Lewis term, so I notice that there is a common between 12 and 75, which is 3. So, removing 3. So, I express it in factored form, but what must I common between them? No? So, okay na ni as my answer. So, whether I express that in factored form or not, no? So, my answer is still not affected. No? So, because there is no reduction to Lewis term that happens after expressing that in a factored form. Now, my third and last example is this one. We are required to solve for 3 items, A, B, C, and my given function is only kana. Rate of change of the slope, kasi itong rate of change of the slope, that is the second derivative of the function. dy dx is the rate of change of the function because it is y that is being differentiated, and dy dx means slope. So the rate of change of slope is the rate of change of that. No? So the rate of change of slope is actually the second derivative of the function because it is the first derivative subjected to differentiation. This is my operator. This is my slope, correct? So, y double prime is needed in A. Okay? So, in order to avoid using the introt, but actually pwede, if you have to use that one, no? So, I just express my given in terms of fractional power. Okay? Y prime, 1/5 times x to power, reduced by 1. Minus 1 is minus 4/5. Y double prime, okay? So, 1/5 times a negative 4/5, reduce further the exponent by 1. So, this is equivalent to 4/25 x to power 9/5. In terms of radical, so there you have the answer. Okay? So, in letter B, what is needed there is the third derivative. So, I must consider the second and then differentiate this further. Okay? So, we have third. Okay? So, power is 9 halves multiplied. All negative. So, the product is positive. X to power minus pila. 14/5. Third derivative, that's 36. That's 25 and 5. So, I have 25. Bringing this down to change the power to plus and converting that in terms of radical. Now, so in letter C, so, what is really needed here? Is it the same as this one? Actually not. Because this means only an ordinary power. Now, so, what is needed is, okay, y to the 5th power. So, I must also raise this to the 5th power. And equivalently, this is x. Okay, so, this is now the required answer. So, if you are not so familiar with the notation, you might be solving correctly the 5th derivative, but it is unfortunately not needed in C. Okay, so for now, be familiar with notations and more importantly, so try to familiarize the different roles and differentiation we are using. Okay, so thank you for watching and see you in the next video. Okay, so bye-bye and good day.